Good afternoon, one and all. I am V. Srinivas Rao, Associate Professor, Department of Electronics and Instrumentation Engineering. Feel privileged to welcome you all for the webinar on IoT on digital transformation. GSSS IETW Mysore is an initiative and outcome of late Professor B.S. Pandit, retired as Physics Professor from SJC Mysore, with a vision to provide quality technical education to women. The institution was established in the year 2003, reflecting the ideas of its founder, and seeks to achieve excellence as an academic institution with advanced research. The institute is accredited with grade A by NAC. Institute offers 5 BE programs, 2 MTech programs, and MBA, all affiliated to VTU Belgavi. The Department of Electronics and Instrumentation Engineering was started in 2006 with an intake of 60 students. The department has qualified and dedicated teaching staff and non-teaching staff striving hard towards the development of the department. The students of the department have secured 11 ranks so far in the VTU exams. The department has established robotics lab in association with eYantra, IIT Bombay, using a grant of 30 lakhs sanctioned by Vision Group on Science and Technology, Government of Karnataka. The department regularly organizes faculty development programs, hands-on workshops, technical talks, industrial visits, conference, competitions, industry institute interactions, etc. First, I would like to welcome today's speaker, Dr. Alvin Yap, Honorary Secretary, Treasurer of Mechanical Engineering Technical Division, IEM, and Head of IoT Research Center at Asia Pacific University, Kuala Lumpur, Malaysia. A special welcome to you, sir. It gives me great privilege to welcome our Honorary Secretary, Srimati Vanaja B. Pandit, ma'am, Sri R.K. Bharat, sir, CEO and Managing Committee Member, GSSR, Srimati Anupama B. Pandit, Administrative Officer, GSSS IETW, and they have conveyed their best wishes. I feel honored to welcome the beloved principal of our institution, Dr. M. Shivkumar. Welcoming you, sir. He is the moderator of this webinar. His specialization is in biomedical instrumentation and signal processing. Under him, one candidate had successfully completed the PhD and guiding 7 candidates in the field of mobile robotics and speech signal processing. I extend a cordially welcome to all the participants from various places for this webinar. I would like to welcome all my fellow colleagues for this webinar. Thank you all. Now I would like to introduce today's speaker. It's my immense pleasure to introduce our today's speaker, Dr. Alvin Yap, is the Honorary Secretary, Treasurer of Mechanical Engineering Technical Division, IEM. Dr. Yap is a senior academician by profession with Asia Pacific University and currently the head of IoT Research Center at the university. Prior to that, he had years of experience designing manufacturing solutions in the US. He holds a BSc and MSc from University of Arkansas, USA, and received his PhD from Multimedia University, Malaysia. Dr. Yap is a registered professional engineer in USA, Malaysia, and a registered chartered engineer in the UK. He holds multiple patents and has been actively presenting research papers in local or overseas conferences. Dr. Yap's research interest includes optimization of Internet of Things and has been providing knowledge and expertise to the industry. I thank you for accepting our invitation to be the speaker of today's event, and I heartily welcome you once again, sir. Now I request Dr. Alvin Yap to start the session.
Thank you, Prof. Rao, for the warm introduction. Heard a lot of good things about GSSS. There are 2,500 students or ladies engineers at GSSS, so kudos to that. Yeah. So thank you, Prof. Rao, Head of Electronics and Instrumentation Engineering, for the warm introduction. Thank you, Principal of GSSS, Dr. Shiva Kumar. And most of all, Thank you, my colleague, Dr. Chituri, for pulling all these things together. Yeah, it's going to be a great webinar. And this is our first collaboration, in terms of webinar between APU and GSS. So we
Yes.
hope that more collaborations can continue. Okay, let me share my slides here. Hello, I am Dr. Alvin, Head of IoT Research Center at APU. Uh, This webinar is a collaboration effort between GSS and APU itself. And of course, as a head of credit, I have to honor the logo, yeah, just put our credit logo there. And for those that tuning in, for the credit club members, welcome and welcome a lot from the APU students. So I'm doing my part to introduce about IoT and digital transformation and what we are doing here at Credit Club. Before I start, let me have a quick intro about credit here. Our center is fairly small, with membership from a dozen of academic staffs and a growing number of students. We aim to promote IoT research projects and activities among the staff and students. We have taken up a number of industry projects and glad that we have some completed. Yeah. Also, we are very happy to have this opportunity to share some of the work that we have done with you. In the next, within 1 hour or so, I'll provide an introduction to IoT and digital transformation, share with you IoT success stories, case studies, latest IoT trends, and some of the projects that we completed at our center. As mentioned, the outcomes for this presentation on this webinar is to recognize the importance of digital transformation and IoT in current trend. Also to describe IoT system by identifying the components accurately, right? So if I were to ask 10 people in this room, what is digital transformation and what is IoT? I would probably get 10 different answers and probably more than that, because it actually all depends on our experience and our background. Okay, as over the years, the definition has been revised and updated. Okay, it just keep changing with the exponential growth in knowledge and skills in IoT area. Originally, the term was first mentioned about 20 years ago by Kevin Ashton. Okay, let's start with the definition of digital transformations. Digital transformation is the process of using digital technologies to create business processes, culture, and customer experiences for changing business and market requirements. It's very broad. Basically, what we want to do, we want to deploy digital techniques, digital skills, digital knowledge to create another set of business experience. Essentially, we have to reimagine how business is done with the digital age using digital transformation. What do we mean by that? Let's take a look at this. I first looked at this quote about a year or two ago. Yeah, it's not new, not created by myself, but it is worthwhile for us to revisit some of this quote. Okay, the world's largest taxi firm owns no cars. What does it mean? Essentially, we have broken down this business, taxi business, into the bare bones, right? So we want to fetch a passenger from point A to point B. And of course, we want to charge a passenger accordingly, according to the distance, according to time. What we don't need is a liability, right? For the company to run the business, of course, they need to own some vehicles. And this was 10 years ago. They have to own the taxis, okay, the vehicle to fetch passengers. But what if you have a win-win situation? You are sharing this liability and sharing the profit with the business owner, in this case, the driver itself. Okay, so this is just one of the business model. The next model we talk about media company. The world's most popular media company creates no content. It doesn't hire journalists. It doesn't have to look for content. It is not running like a newspaper, a traditional newspaper, but it has the information, it has the resources to inform the public. Okay? The world's most valuable retailer carries no stock. It doesn't have a single inventory in the company, yet it is going to be able to promote trades, how they buy things and how to sell the items faster than ever, convenient than ever. The world's largest accommodation provider owns no property. It doesn't own any single property. It's not a hotel. Essentially, it works like a hotel, but it is not a hotel. By now, you probably have an idea what I'm talking about. Yeah, how this company essentially works. The first one, we talk about Uber. Yeah, so it is actually a passenger business. You drive passenger from point A to point B without owning a single taxi, therefore doesn't have liabilities. Facebook, the most popular media company in the world. It doesn't have any journalists. It relies on people's postings, right? So sometimes the news travel faster in Facebook than in traditional journalism newspaper. Alibaba has no stock, unlike some of the inventory management company in the world. It facilitates trades, a trade between a customer and a seller, and he gets commission because of the trades, yeah, between the trades. That is how it survives and how the business flourish. I think the last one is no stranger to us all. Airbnb doesn't have any property, doesn't own hotels, but because of the model, business model that people posting the property and Airbnb able to own commission and take a cut of the transactions, the business model has been able to support this company until it becomes one of the biggest accommodation provider in the world. Digital transformation is happening. It is already happening. It will continue to happen. And IoT is going to be part of it. If you take a look at all these companies, these four companies that we mentioned, IoT is playing a big role. We will revisit IoT by the end of this presentation, and we will talk about how IoT is contributing to the digital transformation. Okay, let's talk about IoT now. The term was mentioned by Kevin Ashton in 1999, about 20 years ago. Yeah, it is the network of physical devices embedded with electronics, software, sensors, actuators, a network that enable devices to exchange data. Back then, Kevin was a British technology pioneer that has done a lot of work in RFID and sensors. He was working as an assistant brand manager at P&G, Procter & Gamble, in 1997 when he became interested in using RFID to help them and manage P&G's supply chain. During the time, Kevin viewed RFID, radio frequency identification, essential to the Internet of Things, which would allow computers to manage all individual devices. Okay, as we just mentioned, we need devices, network, and the exchange of data for IoT actually to happen. Okay, in 2017, before that, each device can work independently and collectively. Okay, in 2017, global IoT platform was 1.3 trillion US dollar. In 2025, it's expected to hit almost 10 trillion US dollar. Huge market. Let's talk about IoT versus ICT spending in Malaysia. Malaysia is a country of 32 million 32 million population. Sorry. Traditionally, we spend a lot on ICT, which stands for Information and Communication Technology, which involves infrastructure, network, servers, desktop, hardware, etc. If you take a look at this, there are virtually no IoT spending before 2015. The reason being is that IoT just came into Malaysia just a few years back, yeah, just right after 2015. By 2020, which is this year, we are expected to spend 9.8 billion ringgit in IoT spending. By 2025, we are expected to hit 32.7 billion ringgit. When we move forward from 2025, our IoT spending is expected to approach and overtake ICT spending. That is how huge the market is, even locally. So, what is IoT exactly? IoT is expected to affect all walks of life. if you take a look at here, the center of it is actually the cloud computing, how the data are being transferred and sent to the cloud. Yeah. Over here in the lower left corner on the consumer market, okay, it affects how we actually do grocery, how we actually spend money doing inventory. Yeah. In a smart home itself, how we actually run our house. Okay. Now in the residential area, we have smart city, we have smart home. That actually affects how we actually transport smart logistic as well, transportation from the home to the work and vice versa. Then we have autonomous car on the upper left hand corner here in the autonomous car. How can we travel even safer, faster, more convenient within the autonomous car itself? How the data can be transferred out to help us drive safer. Okay, now over here in the middle of the picture here, we have smart grid. How can we produce power to be transferred to the customer faster and easier? A while ago, what happens in New York was that there was actually an effort by the startup to actually localize electricity production. What it means by that, they want to form a microgrid, whereas electricity is powered regionally. And the electricity that doesn't have to travel so far to reach the customers. We have local electricity production within the microgrid itself. Okay, now on the right side, you have industrial over here, smart industry or industry 4.0, harnessing the power of data transferred to the cloud. And of course, over here, there is another logistic versus, how can I say, inventory management, yeah, with IoT. We have traditional fields of embedded system, wireless sensor networks, control systems, automation. All others contribute to enabling IoT. IoT technology is synonymous with the concept of smart home, covering the devices and application that support one or more common ecosystems, can be controlled via devices associated with that ecosystem itself, such as smartphones and smart speakers. Right? All these industry collects data and transfer the data via platform to be sent to the cloud. It is easier to recognize, to grasp the importance of IoT if we are able to break it down into components. In this spectrum, I've broken down into three areas, such as devices, network, and the cloud. Let's take a look at the device level. In an industry setting, devices could mean like sensors and actuators. Sensors could mean vibration sensors, temperature sensors, humidity, pressure, so on and so forth. Whereas for actuators, we can have valves, yeah, such as butterfly valves, motors, pumps, and etc. This is in an industry settings. What about residential or even commercial settings? Our smartphones is already a part of life. Then we have desktop, speakers, cameras, tablets, so on and so forth. Those are all our devices level. All this data needs to be transferred to the cloud via network. Over here we have Wi-Fi, Bluetooth, Zigbee, LoRa, Sigfox, NB-IoT, LoWPAN, Z-Wave, 4G, 5G, and so on and so forth. 5G is 100 times faster than 4G, transferring data at 100 gigabits per second. So it's adding in a lot of power to the IoT network. Not to mention that there are a lot of formations that we can form within this network, such as the star or the mesh network. All depends on our application. For example, LoRa is known with the star network, whereas Bluetooth is known for the mesh network. Okay, so depending on our application, we can pick and choose which network for our application. For the cloud platform, we will have Azure, AWS, Linux. The new addition, new player to the game are such as Google Cloud and Alibaba Cloud. We will see a lot more competition among this cloud provider, yeah, because we definitely need somewhere to store our data and to display our data. All these data provider are going to get into this game because they know how lucrative and how profitable IoT market is. Okay, let me share with you an IoT success stories. This company is called Nest. Yeah, is providing a home automation system, IoT system, to send data to the cloud. This data, initially the data sent are temperature and humidity. You can see it being sent right away. Other data could involve vibration, yeah, vibration data that can tell, and even the proximity data within the home itself. Okay, data can be available as easy as your fingertips. Can be online or can be even on an app in a mobile phone. Let's talk a little bit of the history. How the company came about. In 2010, there were two engineers, yeah, coming out from Apple. It's the Apple. Everybody knows what Apple does. They produce some of the most successful computers in the world. So Apple, they came out. Their name was Tony Fadell and Matt Rogers in 2010. Yeah, so they actually came out and start up their own company. They named the company called Nest. They started with 2%. 3 years later, the company grew into 400 people, 400 staff. At the time, they are able to sell the company to Google. How much? You guess. It's a lot of money. They are selling it for 3.2 billion US dollar. Phenomenal success for an IoT company. So these are some of the facts and figures that the company actually produced, as a example, as a good example of IoT itself. I like to share this story because a lot of people say that IoT was not profitable or not was almost impossible. But right there in front of us, there is this IoT company making lots of money, right? And just producing a very simple solution and transferring data to the cloud. All right, the trend in IoT itself, yeah, a lot of things are going on even right now within the IoT industry. There are a few sectors that's worth noticing, worth paying attention to. Manufacturing, it has been the backbone of IoT. Yeah, it goes with production maintenance, inventory management, and big data analytics. For the logistics, everybody knows how we need to track the trucks better, how to have the preventive maintenance better on the truck itself. And of course, healthcare is getting a lot of attention lately because of the COVID-19 virus, yeah, because of the lockdown that we experience. Healthcare and of course, IoT can be used for patient monitoring, equipment management, and of course, disease monitoring. This is the latest addition, and it has a lot to do with COVID-19. In terms of security, IoT can be used for advanced management and AI and edge computing. Now, there are a lot of work being done here on edge computing. The trend now is have the computing done or data analyzed in the devices itself. You still remember the three components, right, that I just showed you before. So what happened was that we want to analyze the data at the edge, at the devices level, before being passed down the spectrum, before it being passed to the network, and before it is being passed to the cloud. By doing so, we can actually being selective of what are the importance of the data being transferred. For example, in the CCTV itself, you only start to transfer data monitoring, yeah, monitoring of an area in a supermarket itself, for example. We can only start transferring data when we detect a presence of a person. Okay, so when the person are detected on an area, then data can be transferred. If there are any irregularities, if you scrutinize the video and program it in such a way that you can, if you know there are any irregularities in that area, then you can start transferring. Then you can save a lot of bandwidth, right? And data transmission as well in terms of costing. Okay, so a lot more work can be done in terms of security. I would like to share with you some of the work done that we have done here at Credit, our IoT Research Center. The first work that we have done is vibration analysis. Vibration is important because it accelerates wear and tear, especially in the mechanical driven industry. What you see here on the left hand side is a large gear housing. All right, the gearing coming from this is a helical gear transferring the gear with a gear teeth ratio of very large and a small gear. Okay, now what you see at the bottom here, lower left corner, is a silicon wafer. The machine to produce silicon wafer is very important and very critical because any vibration can actually affect the production of silicon wafer, and it is very sensitive in such a way that minor vibration can affect the whole batch, and it can destroy the whole batch of producing the defects on the silicon wafer itself. What you see here on the right side is some of the vibration detection tool on the market. Cost a lot of money, cost up to 10,000 US dollar, with limited range and limited transmission capability. It can only transmit with cable, and it can store with very limited amount of memory. Okay, so this is what we have. We decided to take up this challenge, and we built a solution in-house at our IoT Research Center. We use what is available on the market. In this case, a sensor, a vibration sensor, hook up to a Pi, to a Raspberry Pi here, and we program it in such a way that it can be used to transfer 6,400 data per second. It's a real-time data, real-time transfer via Wi-Fi. And of course, on the upper right-hand corner here, this is an AC drive controlling the AC motor, the speed of the AC motor in terms of RPM, in terms of torque, so on and so forth. The data is being transferred at 6,400 data per second via Wi-Fi, and we are able to transfer it with no problems at all. The systems are being tested. If you take a look at the right side here, this is a multi-million-dollar silicon wafer machine. This machine is used to produce a silicon wafer, which is used for integrated circuits, silicon chips. It is located in Penang, running at AMD, AMD facility. So do you look something familiar? If you take a look at the center here, the sensor here at the center, let me just take one more shot that you can see closer. I take a picture of this and I rotate it 90 degrees. So this is actually the sensor that we developed here. Look familiar of what we have here on the AC motor itself. Okay, the system has been deployed, and of course the project has been commercialized. Customer is happy that they are able to get the data online. So how does the data look like? This is how the data look like. What you see is before and after, which is before it is with the vibration detection tool on the market. What you can see down here is the tool that we developed, 6,400 data per second. Above, 3,200 data per second versus 6,400 data per second. In terms of frequency, you are able to see a lot more defects being plotted. Otherwise, you could have missed it. Excuse me. In the range of 600 hertz, what you can see here is a spike, right? In 3,200 data per second, it doesn't show. However, it is being shown now, transmitting at 6,400 data per second. We will be able to plot a lot more defects. They can be shown here, which is critical, especially when you are specialized and expert in vibration analytics. Okay, vibration monitoring. It's very important. The more the data, the better. Okay, then we can have a lot of statistical tools. These are the data that can be plotted and deployed in the IoT dashboard real time. So in terms of standard deviation, skewness, kurtosis, all these statistical variables, RMS, max or minimum vibration, vibration variables. Okay, a few years ago, we are actually working with a glove manufacturer to produce and detect tank wearables. Yeah, we can't name the glove manufacturer. But what they were doing back then, they were detecting the tank wearables with a tool, with a device, similar to what you can see on the right-hand side. They want to attach a probe. Yeah, they will attach a probe on this device, and from here, they insert it into the tank. Then they can detect the latex, the composition latex of the tank itself, the temperature, and of course the pH level, yeah, of the tanks, along with other variables such as permittivity, so on and so forth. All these were done by operators manually. Every hour or so, you have one operator going to dip this device into the tank to measure the variables in the tank itself. So what we can do is, how can we automate this process using IoT? Yeah, so we have developed a system in such a way that we have to take these variables out of the tank, and we have to propose a range of devices and a reliable devices, not just using Wi-Fi. We have to use something new called LoRa. The reason being is that, part of the reason being is that Wi-Fi is fine, especially in the short range. However, in a factory environment, Wi-Fi will tend to disintegrate. Your signal will tend to disintegrate, especially when it's close to metals. There are too many metals in the production floor. So we have to propose something else. In this case, we propose LoRa. LoRa stands for long range, low power network. Yeah. Or it can mean low pan. Yeah. So LoRa is encrypted, it is safe. The moment that we send data through the LoRa network, the things network, it will be encrypted already, up until it's being decrypted on the other end of the transmission. So we have LoRa gateway, and we can actually make it a lot more reliable, a lot more safer by programming into a private LoRa. We can actually identify which sensors to transmit data to our LoRa gateway. So with this, we move on with our project, and we are able to develop something like this. What you see on the left side is the sensor module. If the self-powered sensor module, we have actually a sensor here. It's a humidity, temperature and humidity sensor connected here to our circuit board. This circuit board is self-developed, and we developed here at the university at Credit, right? Along with a controller and a LoRa transmitter. Yeah. So, and of course, we have a GPS transmitter here as well, being powered by rechargeable batteries. This is our sensor module. On the right-hand side, this is what we have developed called a LoRa gateway. We have a LoRa receiver here at the other end, at the lower corner here. And then we are using this data are transferred by this LoRa receiver to the Pi, the Raspberry Pi, which acts as a gateway. Of course, we just use it as a power to our laptop. Essentially, this is a whole system, how it looks like at the bottom. Okay, it will be able to show the location, the temperature and humidity at any one point. This is on a general scale. You can even use it in the outdoor environment, even though like we mentioned, we can use at a glove manufacturing facility, depending on the sensor being connected. Yeah, LoRa signals transmission and how can I say, transmission and reception itself can be 15 kilometers direct line of sight. If I move this guy, if I move the sensor module away from the receiver, 15 kilometers direct line of sight, they'll still be transmitting. Yeah. So these are some of the projects that we have done here at IoT Research Center at APU. Some example of how these are being done, the display on the more like a handphone level. So those are the tank variables. You have the line speed, acid tanks, alkaline tanks. All right, this is how it has been deployed at the tank itself. Shortly after we show this project to our industry partner, they take this project and move forward, and now they have automated almost all the tanks, transferring the data from the tanks to the cloud. Okay, so they are just some of the contribution that we have to the industry. This is a third project, kind of interesting. The moment we call this IoT drone, warehouse IoT drone, is its ability to transmit data, right, to the cloud. Let me give you a little bit of background of this inventory checking. Manual inventory checking, yeah. Once every month or once every 2 weeks, depending on which industry you are in, you are required to conduct inventory checking, just to make sure that whatever the inventory that we have on the shelf is the same as what we have in the log sheet, in the checks. Inventory checking is repetitive, it is tedious, it is time consuming because we have to do it again and again. Yeah. And it produces a risk of injury. Why? How does it happen? Just imagine this, we have a person here doing some checking on the shelf, and there are some stocks on the higher level that he needs to get into. However, you need a stair. What if the stair is not available? Yeah, that he cannot get to the higher level. Then he needs to figure out another way to get to the higher level, you know, so that the stock can be checked. Right? If the stair is not available, then actually it provides a risk of injury. Can we use a robot to do the stock checking? Yes, certainly. What about ASRS? Can be done. Automated storage and retrieval system, it can be done. However, it comes at a cost. How much of a costing are we allowed, to spend on this inventory checking? How much inventory, how much ROI are we going to need for this inventory checking? So at our ABU Research Center here, Credit, we propose the use of drone, yeah, for inventory updates. We have done some preliminary testing, and we think this can be done. Yeah, so preliminary work has been done. Actually, we done a lot of competition with this project. Okay, let me show you what we have been done. Okay, I'm going to show you a video about a minute or so. Just bear with me on this video. Okay, this is being shown at an exhibition that we conducted with the Ministry of Higher Education here in Malaysia. Wait, let me just play it from here. So you're actually seeing this camera view of a drone itself. This drone is scanning the barcode on the boxes, yeah, while it is flying, checking. And this barcode can be scanned and data can be updated, can be output to an Excel spreadsheet. And from there, it can be linked to an API or any ERP software. Okay, just now you have just been shown with a video of how the drone is doing manual inventory checking, yeah, replacing manual work. So what I'm going to do next is to show you another case study. But before that, I want to talk a little bit about this project. We have done quite a lot of work on this project. Right now, we are in a stage where we need to explore the next stage of research or pushing it to the market per se. Yeah. So a lot of work, but hopefully we'll get there. Okay. So this is another case study. Right. So we are thinking about this IoT on COVID-19. A lot of talks, a lot of areas that can come into COVID-19. Now, is COVID-19 a crisis or an opportunity? For many people, it is a crisis. A lot of people has lost jobs. A lot of business has gone under. But it is actually an opportunity for some people to an extent. Actually, this is a kind of uh, a spectrum of an extreme. You have some people doing well on one spectrum, and a lot of other people are doing not that well on another spectrum. So there are opportunities here. For most people, the glass on the left is half empty. For engineers like us, we see the glass as half full. Because engineers like us, we like to develop solutions and we like to fix problems, right? So I would like to present you for this IoT as a part of opportunity. Just so that you know, I know some people that are doing quite well here. People that are in the online business, or even online training business, they are doing very well, right? As opposed to some people that relies on hotel business or tourism business and so on and so forth. We just have to adapt. Yeah, I just have to adapt. We just have to change. And what we need to do to present this period as an opportunity, especially for engineers. Okay, let me give you some examples of what is happening here. This is not new. This has been taken in the early outbreak of the virus itself, probably around March or February or March earlier this year. Okay, once after the virus outbreak, Germany has done a lot of work on contact tracing. I'm just giving you one example of how IoT can be used in contact tracing. Okay, Germany has done it because they like to use that they want to link these lab results, yeah, with via notification to an app, via phone, even with the lab result via contact tracing. Shortly after, Apple and Google are teaming up on a contact tracing app itself. They are joining here quite late itself on Apple and Google, these two big multinational companies. Yeah, they are joining here quite late. They are starting in May. They say the result will be launched in June, but I never really follow up after that. But I believe they have something that is still working on it. Yeah, actually, once this Apple and Google jump into it, there are a lot of researchers that take advantage and takes this opportunity as well. In Malaysia here, there are quite a lot of business that develop a system for thermal tracing, thermal checking, develop apps itself to help the business on contact tracing. Okay, now in our center, we have developed something similar. At least we are working on it though. We are doing something similar for contact tracing, but we are using hardware, not entirely software. What these big companies are doing, they are doing a lot of software with the apps. On our center, we would like it to be automated via hardware. I can't tell you a lot of work, but it's just something that we show, it's still a work in progress that we collaborate with another hospital that we are working on this. Okay, and of course, there are other watches, smart watches being launched to monitor the coronavirus spread itself. This is another case study that we are working on. It's called Industrial Sensor Box. This box itself requires Wi-Fi connection. The reason being that we developed this box is to automate the signal collection process, yeah, from various sensors. There are so many sensors available on the market from manufacturers such as ABB, Omron, Allen Bradley, Mitsubishi, Hitachi. There are so many sensors. But as long as we are able to get the sensors that's from the signal of 0 to 5 volts, we can collect the signals into this box and we are able to send to the cloud. It's developed by one of our top researchers here at APU, IoT Research Center. Okay, it is friendly. It can connect up to 4 sensors at one time. It is IoT based. The output display can be monitored via MQTT based software or what we call node rate. Can be accessed anywhere at any time. So this is what we call an industrial sensor box. Some examples of how this sensor box being launched, how it looks like. Yeah, we can have up to 4 analog values with I2C data. Yeah, so we are currently working on the fourth version. Yeah, fourth version of the sensor box itself. So hopefully this one completing soon, that we can go and test in the industry. In the summary itself, what we have seen, what I've shown you in the last 45 minutes or so, we have talked about the importance of digital transformation, and IoT has been demonstrated. The IoT system can be categorized into three segments of devices, network, and platform. And also, we have demonstrated the wearable industry, how IoT can be used. Now, let me have a quick check on you. What are the three components of IoT? In a regular day, I can get feedbacks from my class, from my students, but I can imagine that on an online webinar, so you can probably type some answers here in the chat box, okay, so that we can get the moderator to have us an answer. But let me just repeat, yeah. So the three components of IoT consist of devices, network, and platform. Okay, it is very difficult for you to get one expert measuring, in all these three areas. Okay, but we are still learning every day at our IoT Research Center. We are still working on it, and hopefully one day, that we can produce some of the best quality products, best system available. Where can IoT be applied? The answer is on your right hand side. It's virtually everywhere. You can apply in a farm, in this case, which is our local palm oil plantation, or it can be applied in smart home, yeah, residential area. In a farm itself, it's getting more and more frequent that we are getting inquiry where how we can send data such as water level, moisture level, the health of the tree itself, the health monitoring of the tree itself, and even fertilizer level and pH level. All this data needs to be monitored. So we are getting a lot of inquiries. Now we just have to formulate a way to work on it, yeah, to develop the system and make it work better. Smart home is not new, yeah, so it's available. However, what is new is the method. How can we even transmit the data faster, easier, and cheaper? All right, so all these three values needs to be investigated so that we can proceed even further, with our IoT solutions. For conclusion itself, I would like to quote you two quotes, not just one, but two. These two quotes are fairly important. I'm going to start with the one on the right side because of this is what is said by Kevin Ashton, the original proposer of IoT. The IoT has the potential to change the world, just as the internet did, maybe even more so. So he can even foresee that IoT is changing our lives faster than ever. Okay. Now, what we have on the left side is proposed by Tony Fadell itself. Just now, I show you some of the success story. One of the success story by Nest. Tony Fadell is one of the founder and CEO of Nest Labs. What did he say? He said the truth is homes change over time and technology has to adapt. Yeah. So we're not trying to do everything at once. Even he himself, if we read it again, and you know that even he himself has to admit the pace of changes is happening way too fast. Yeah, the IoT is changing way too fast. We have to adapt. Wait for it has to change over time and wait for the technology to adapt and try not to do everything at once. This is the essence of what he's saying. If we launch too fast, you can have a backdraw. You could have a backdraw, okay, from what we are doing. So with this, I conclude my webinar. And do you have any questions? Moderator, do you have any questions? Oh, okay. Okay. Okay, wait. I'm going to stop sharing on my slides. There is actually a question here by Laditha. To take up real-time challenges using IoT, what are parameters to be considered? The question is, it really depends on the application. Yeah. So what IoT wearables are we looking at? If you talk about smart home, yeah. So if you talk about smart home, you need to look for the sensors that are in this area. For example, if the gate being closed, so you need proximity sensors. Yeah. Is the lights being off? You need infrared sensor. Or is there any burglars in the house? You need PIR sensors. So all these sensors actually depends on the application itself. And this will be very different from the example that I just gave you on the oil palm plantation. Okay, from the oil palm plantation, we will be looking at pH level, even water level, moisture, even permittivity level, permittivity value, and so on and so forth. So there are a lot of different parameters that we can play with. Hope that answers your questions, Lalitha. What skills are required to work in an IoT industry? Good questions. What skills? Enormous variety of skills. Now, what we are this question by Muhammad. Thank you for your question, Muhammad. The question says, what skills are required to work in an IoT industry? Both hardware and software. That's going to be my short answer. And of course, a more evaporative answer will be your skills in sensors and your skills in programming, even your skills in selecting the right controllers, transmitting data, network. Remember the three spectrum that we talk about, devices, network, and the platform itself. You have to be good at all three. It's not easy. It's not easy, but it's possible that you have to be good, but not perfect. Yeah. So you have to learn all the skills within the IoT components itself. Again, the skills will be programming on devices, selecting the best devices, selecting the controllers, using the best network available, transmitting data, and then of course be the best, being the best programmer in the platform. Just the platform itself is already a variety of platforms available. Yeah, so you need to be good at these three components. Thank you, Mohammed, for your questions. Any limitations of IoT technology? Yes, there are. Glad that you asked, Vishnumurthy. Yeah. So again, it comes back to these three components. Each component has its own limitation. But to answer your question, I would just pick one. Yeah. For example, a network, just the network itself. Let's say you want to develop an IoT solution to send the data to variables from the ocean, yeah, from the middle of the ocean. So what network are you willing to use? Are you going to be deployed in the middle of an ocean? Clearly, there's no Wi-Fi there in the middle of an ocean. There's no Wi-Fi, and you can create your own Wi-Fi if you want to, but it will take plenty of effort, right? So what else? Can you use LoRa? Possible, but then where is your gateway? How do you deploy your gateway? You need to think about this. Can you use satellite? Yes, certainly. This is the limitation. Satellite, you transmitting your data to the satellite is going to cost a lot of money. Possible. Cost is the limitation. Okay, I just give you one example, and I hope that answer your question, Vishnu. Thank you. Yeah. What about the security of data over the internet? Thank you, Lalita. Good questions. IoT is the precursor of data analytics, or even for machine learning, or even for cybersecurity. Without IoT, you didn't get data. Okay, that is why we are always seen as a pioneer of this industry 4.0. We need to figure out a way how to get data. When we talk about data security, right? So in a way, you start by transferring the data which is less critical. I would say less critical, and you can transfer a lot of sensor data, for example, temperature data, humidity data, which makes no value for other people. And when other people take a look at your data, they wouldn't understand what you are trying to do. So what is the value of the temperature data, for example? What can they do with it? Now, and also the other point is when you do the data transfer, we are single direction only. unidirectional. With one direction only, you can only send and display the data, and you don't do control, which is very important. When you don't do control on your actuators or devices, it makes it less reliable for cyber attacks because you're only sending it one direction, right? And the data doesn't come back and doesn't control your processes. The things happen when you start to control your process over the internet, and that is what is susceptible to cyber attacks. So when that happens, you need to refer to cybersecurity engineers. We can't help you. At our center, we have, but I would always refer you to another center, which is a cybersecurity center. Over here, we do a lot of IoT, and currently we have quite a number of projects on IoTs already. Thank you for your question. In your opinion, is IoT a future technology of the world? Thank you, Amiza. It is already happening. Realize it or not, it is already happening. These terms was created 20 years ago by Kevin Ashton. It doesn't really caught the wave until 10 years ago. Slowly, it was 10 years ago that was slowly picking up, and it became hot. It became the peak when Steve Jobs gave the world the iPhone, introduced iPhone to the world. iPhone immediately become an IoT device. And a lot of apps, a lot of programs are being designed into this app, and data are being transferred at an enormous rate. So all about data, how the sensors, how the app are being transferred. Yeah. So is it a future technology? It is already happening. If you carry your smartphone, it is already an IoT technology in your pocket already, and you are being tracked without knowing it. So the website that you go to, yeah, in your phone itself, the places that you go, even the voice that you speak are all being used. The data are already transferring to the cloud, with or without, of course, your consent. So this is something that is a bit scary, but it is happening. IoT is happening already. That is just on a personal level. But on application level, I still believe there are a lot of rooms to grow, especially in the COVID-19 area. Yeah, so a lot of healthcare area. How can we make people safer with IoT? How can we track people more effectively in terms of which places they go, who they get into contact with? That is my team has been working on. Yeah. So thank you, Amiza. Could you please give some inputs and adopt IoT in real-time agriculture field? This is given by Naga. Yes, sure. I just gave you an example of palm oil, how the palm oil plantation. You can definitely use this example for other application. Years ago, when we first started this center, we actually go into aquaponics. Yeah. So how can we transfer the data in aquaponics, such as water level, pH level, permittivity, or permeability? So many other chemicals composition into the water itself. We are transferring the data real time to the cloud, and we are monitoring it. So this has been used in aquaponics, just one of the few that you can consider itself. Thank you, Naga.
Hello.
Yes, hello, Prof.
Hello, sir. How are you, sir?
I'm fine. How are you, Dr.
Fine, sir.
Shiva?
Yes,
Shiva
sir.
Kumar.
Chukumar,
Hi, good to
principal of
see
this
you.
institute. Sir, I
Yeah,
have a small question regarding this IoT in
yeah,
maybe in the
sure.
agricultural field. See, in
Yes.
the agricultural field, suppose if you want to use any IoT application, it depends on the battery life. Hello.
Yeah, I'm here. Well,
The
what
battery
do you
life
mean
is
the
very
better life?
important, and suppose if the battery gets drained, how do you
Oh,
recharge? How do you recharge?
right. Uh, there are actually a lot of research going on in this area in terms of battery life. Okay, let me tell you an example. Yeah. What you can do, there are actually multiple efforts into this area of research. You can miniaturize your controller, just make it smaller so that it requires less ampere, less current to run the devices. Okay, that's one. And of course, with less ampere, if you can reduce the voltage, it'll be great as well. Otherwise, you can just reduce the current for now. The next thing is to limit the transfer rate, the data transfer rate. Instead of transferring the data like every 5 minutes, or every 5 minutes, you can transfer the data every 1 hour or so. Okay, so you can limit that. This one comes with the programming, and you can activate the sensor whenever you need to. Right? So this is just another way. Of course, you can provide external power to your sensor using a lot of renewable energies nowadays. You can use wind or solar. That is something extra that you can for power your sensor. Hope that answers your question, Dr. Shiva.
Okay, sir. And another thing is, see, for this IoT application, you require the internet facility, the internet connection, stable
Yes.
internet connection, and in the agricultural field, can you expect a stable internet connectivity?
Yeah. Okay. That is very good question. If you take a look at the network spectrum that I just presented, there are a lot of network capability available, not just Wi-Fi. Wi-Fi is just one of them. You can use GSM, you can use 5G. All right. So even 4G, 5G, even LoRa. There are so many options nowadays compared to when we first started like 5 years ago. There are very limited options. In Malaysia, we have something called Sigfox now, even NB-IoT. Yeah. So not necessarily Wi-Fi. Wi-Fi is not ideal for outdoor. So there are a lot more options. It all depends on the field. What is available on the field, how big the area is, and so on and so forth. Well, you have to do some survey. I wish I could help you, but I can't go there.
Okay.
Yeah. So if no, you have to do some survey and see where is the closest towers, telecom towers available, and where is the closest point of contact. There are a lot of networks available. I mean, at least in Malaysia point of view, there are quite a lot. I'm not familiar with India telecommunications industry, but I believe they are. I believe they are. Yeah, there are network that you can tap into. And if you can't, then you can deploy. You can start working on LoRa. Can deploy the network there. So hope that it helps you, Dr. Shiva.
Okay. And another thing is, see, the deployment of the sensors. Because in the agricultural field, there'll be a lot of process going on. The tilling of the land, the crops will grow. We have the
Right.
different stages of the crop growth, and
Yes.
the placement of sensor and getting the information through the sensor for coming to some conclusion. It is somewhat difficult compared to the getting information in the urban environment. What are the
Yeah.
challenges the people have faced for IoT in agricultural field?
Yeah, I understand your question. This is actually IoT is not for all agriculture. So when it comes to the land clearing, I understand about land clearing. When you talk about land clearing itself, it just has to be removed. When you remove the plantation itself, it has to be removed. So that it is safe. Otherwise, there's no point. You spend the money, you install the IoT sensors on the land itself, but then when it comes to land clearing, then everything goes together with it. So it doesn't make sense. But I have seen a lot of people having successful IoT application in in-house farming, greenhouse farming. You understand greenhouse farming? Yeah, where we have an area in the warehouse, then we actually control the environment. So when we control the environment, we have sensors like doing aquaponics. This is a good example because I've seen how people done it. Aquaponics, they are able to transmit the data real time, and they are able to doing it well in a controlled environment. For outdoor, we will run into challenges. You just mentioned power, and you just mentioned clearing, which is very valid examples. This one we cannot avoid. Something that we cannot avoid, but hopefully that we can overcome the challenges soon.
Any other question?
Yeah.
Hello?
We think there's all questions that we have, unless the audience have more questions. Okay, so I
Okay.
believe there's no more question. Thank you very much for having me
Thank
today.
you very much, sir, for taking your spending your valuable time to give the webinar on IoT applications. And on behalf of the institute and all the participants, I thank you for sharing your experience in the field of IoT to all the participants of this webinar, sir. And also, I
Thank you,
thank
Dr. Shiva.
Dr. Venkatratnam for coordinating this event, and also congratulate the Department of Electronics and Instrumentation Engineering of our institute for coordinating with you and Dr. Venkatratnam in organizing this webinar.
Okay.
Thank you
All
very
right.
much, sir.
Thank you. Yeah. So in turn, APU, on behalf of APU, thank you as well. Yeah. This is a first collaboration, and we hope more collaborations to come in future.
Definitely, sir.
And glad that we are able to share our knowledge together.
Definitely, sir. We want to have the MOU with the APU, and we are in that process. And definitely we want to have more collaborative programs between our institute and the APU, sir.
Yeah. True. All
Thank you
right.
very much.
Thank you. Okay.
Thank you.
Bye bye. Thank
Bye,
you for
sir.
the audience. Bye bye.